Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on estimation. If you need any extra help on estimation, if you go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video number 215, there's a dedicated video tutorial there on estimation. Alternatively, you can scan the QR code. But in this video, we're going to focus on the video solutions to practice questions, so let's get started. So question number 1 says, by rounding each number to the nearest 10, estimate the value of 39 multiplied by 21. So we want to round each of these numbers to the nearest 10. So 39 to the nearest 10, well, if we were to choose between 30 and 40, it's closer to 40 than 30, so we're going to choose 40 there. And 21, well, it's closer to 20 than it is to 30, so we're going to choose 20 there. So 39 multiplied by 21 is approximately equal to 40 times 20. Now let's work out what 40 times 20 is. 4 times 2 is equal to 8, and then we'll add on our 2 zeros. So the answer would be 800. So that means that our estimate of 39 multiplied by 21 would be 800. That's our estimate by rounding each of those numbers to the nearest 10. And just out of interest, if we were to work out 39 multiplied by 21, that's equal to 819. So 800 is pretty close to that. So it's a good estimate. Okay, let's look at our next question, question number 2. So question number 2, we've been asked to estimate 2.9 multiplied by 401. So let's round both of these numbers to one significant figure, because that'll just make it a little bit easier whenever we're estimating the answer to this. So 2.9 to one significant figure, if we round that to one significant figure, well, it's closer to 3 than it is to 2, so we're going to choose 3. And 401, if we round that to one significant figure, then that would be 400. It's closer to 400 than it is to 500, so multiply by 400. So we're going to work out 3 multiplied by 400. So 2.9 multiplied by 401 is approximately equal to 3 times 400. And then if we work out 3 times 400, well, 3 times 4 is equal to 12, and then we've got 2 zeros. So that's equal to 1,200. So our estimate is 1,200. And that's it. We've estimated the value of 2.9 multiplied by 401 to be 1,200. And let's just check that. If we do 2.9 multiplied by 401, the answer is equal to 1,162.9. So 1,200 is pretty close to that. Okay, let's look at our next question, question number 3. So question number 3, we've been asked to work out an estimate of the value of 7.1 multiplied by 97. So let's round both of these numbers to one significant figure. So 7.1 to one significant figure, well, that would be 7, because 7.1 is closer to 7 than it is to 8, so 7. And then 97, if we round that to one significant figure, so either 90 or 100, well, 97 is closer to 100 than it is to 90, so we'll use 100. So if we work out 7 times 100, that's equal to 700. So 7.1 multiplied by 97 will be approximately equal to 700. So that's our answer, 700. That's our estimate. And let's just check that. 7.1 multiplied by 97 is equal to 688.7. So 700 is pretty close to that. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to estimate the value of 908 over 2.03. So that's 908 divided by, let's write that out, 908 divided by 2.03. So let's round these numbers to one significant figure. 908, well, that's closer to 900 than it is to 1,000, so we're going to use 900. So we're going to say it's approximately equal to 900 divided by. And then instead of 2.03, if we round that to one significant figure, that would be 2. It's closer to 2 than it is to 3, so divided by 2. And 900 divided by 2, half of 900 is 450. So our estimate for the value of 908 divided by 2.03 would be 450. And that's it. And let's just check that. If we do 908 divided by 2.03, that's equal to 447.29 and so on. So 447.29, that's pretty close to 450. Okay, let's look at our next question, question number 5. Okay, so question number 5 says, Isla's using her mobile phone while abroad. So she's using her mobile phone when she's abroad, and she received 3 minutes of phone calls at 88p per minute. So she has to pay 88p per minute for the phone calls she's received. She made 7 phone calls at a cost of 71p per minute. So it's actually cheaper for her to ring out than it is to receive them. And then finally, she sent 4 text messages at 52p per message. And we've been asked to estimate the total cost of Isla using her mobile phone while abroad. So what I'm going to do in this question is, rather than using 88p, I'm going to round that to be 90p. I'm going to round it to one significant figure. And likewise for 71p, I'm going to round that to be 70p. And 52p, I'm going to round that to be 50p. So we've just rounded those amounts to the nearest 10p and rounded them to one significant figure. In terms of the 3 minutes, 7 minutes and 4 text messages, well, I'm going to actually keep those the same because they're already one significant figure. So in terms of the calls that she received 3 minutes of calls, and we've rounded it to be 90p a minute. So let's do 3 multiplied by 90. And she made 7 minutes of calls at 71p a minute, where we round out to be 70p, so it's going to be 7 multiplied by 70p. And then 4 text messages, and we've rounded that to be 50p each. So multiplied by 4 multiplied by 50. So let's work out each of these and then add them all up to find the total cost. So 3 times 90, well 3 times 9 is 27, and then put on the 0, so 270 pence. And then 7 times 70, well 7 times 7 is 49, and then put on the 0, so that'll be 490 pence. And finally 4 times 50, well 4 times 5 is equal to 20, and then put on the extra 0 will be 200 pence. So we've got 270 pence, 490 pence and 200 pence. Well, if we add those all up, that'll be a good estimate for the total cost of Isla using her phone. So let's add these up. 0 plus 0 plus 0 is 0. 7 plus 9 is equal to 16, plus 0 is 16, so put a 6 down and carry a 1. And 2 plus 4 is equal to 6, plus 2 is equal to 8, plus another 1 is equal to 9. So we've got £9.60. So our estimate for the total cost of Isla using her mobile phone will be £9.60. Now let's actually work out what it would be just out of interest. And so 3 times 88 plus 7 times 71 plus 4 times 52, just working this out on my calculator, gives me an answer of £9.69. So £9.60 is a good estimate. Okay, let's look at our next question, question number 6. Okay, so question number 6, we're told that Stuart buys 72 packets of crisps at 19 pence each, and we've been asked to estimate the total cost. So you buy 72 packets of crisps at 19 pence each. So if we were working out the exact cost, we would do 72 multiplied by 19. But we're estimating here, so let's round these numbers to one significant figure. So instead of 72 packets, we're going to consider 70 packets, and instead of 19p each, we're going to round that to be 20p each. And then if we just multiply them together, that'd be a good estimate, so that's approximately equal to. So 72 times 19 is approximately equal to 70 times 20. And then if we just do 7 times 2, that's equal to 14, and add on our 2 zeros. So it'll be 1,400 pence, or in pounds, that'll be £14. So our estimate for the total cost would be £14, and that's it. Okay, let's look at our next question, question number 7. So question number 7, we've been asked to, by rounding each number to the nearest 10, estimate the value of 82 times 48 divided by 198. So we've got 82 multiplied by 48 over 198. So let's write that down. So 82 multiplied by 48 over 198. So let's round these numbers to the nearest 10. So that would be approximately equal to 82 to the nearest 10 would be 80. 48 to the nearest 10 would be 50, and 198 to the nearest 10, well, that's either 190 or 200, so it's closer to 200, so it's going to be over 200. So we're going to work out 80 times 50, all divided by 200. So let's work that out. 8 times 5 is equal to 40, so let's put down a 40, and then we've got 2 more zeros, so 2 zeros, divided by 200. And now we just need to work out what 4,000 divided by 200 is. There's a few different approaches for this division. One approach is actually to do the bus shelter method and do 4,000 divided by 200 using the bus shelter method. How many 200s go into 4? 0 remainder 4. How many 200s go into 40? 0 remainder 40. And how many 200s go into 400? That'll be 2. And how many 200s go into 0? That's going to be 0. So that's going to be 20. So that means that our estimate is 20. Another way to do this division is actually to say, well, if you have 4,000 divided by 200, like equivalent fractions, you can divide both the numerator and denominator by the same amount. So if we divide them both by 10, we get 400 divided by 20. If we divide them both by 10 again, we'll get 40 divided by 2, and then if we do 40 divided by 2, we get that's equal to 20 as well. So there's a few different approaches you can do for that division. You could use the bus shelter method or just cancel it down like a fraction and then work it out. So that's it. So what we've done in this question is we've rounded the numbers to the nearest 10, and then we've worked out our estimate. And again, just out of interest, let's do 82 multiplied by 48, get the answer and divide by 198, and that's equal to 19.878787 and so on. So 20 is pretty close to that, so it's a good estimate. Okay, let's look at our next question, question number 8. So question number 8, we've been asked to work out an estimate for 58.8 multiplied by 20.9 divided by 101.4. So let's round these numbers to one significant figure. 58.8, well, that's approximately, well, we're just doing approximately equal to because we're rounding them. That's going to be, if we round that to one significant figure, that'll be 60. Multiplied by 20.9 to one significant figure, if we round that, that'd be closer to 20 than it is to 30. Divided by 101.4, if we round that to one significant figure, that'll be 100. So 58.8, we round it, is 60. 20.9, when we round it to one significant figure, that's 20. And 101.4, when we round it to one significant figure, that'll be 100. So we've now got 60 times 20 divided by 100. 6 times 2 is equal to 12, and then we've got 2 more zeros, 0, 0, and then that's divided by 100. So we've got 1,200 divided by 100. So let's divide by 100. Well, 1,200 divided by 100 equal to 12, because you need to multiply 100 by 12 to get 1,200. Another approach would be to consider, well, if you divide by 100, you can take off these 2 zeros to leave you with 12, or move the digits 2 columns to the right, and so on. So there's a few different approaches you could use, but the answer would be 12. And that's it. And actually, again, this is on my calculator. Let's work out 58.8 multiplied by 20.9. Get the answer, divide by 101.4. And the answer to that would be 12.1195 and so on. So 12 is pretty close to that. So that's a good answer, good estimate. Okay, let's look at our next question, question number 9. So question number 9, we've been asked to estimate the total cost of 31 televisions at £196.50 each and 19 DVD players at £50.99 each. And we've been asked to clearly show how we've obtained our answer. Okay, so let's round these numbers to one significant figure, just make it a bit easier. So instead of 31 televisions, we're going to consider 30, just rounding it to one significant figure. Instead of £196.50, we're going to round that to £200 to one significant figure. Instead of 19 DVD players, we're going to choose 20. We're going to round it to one significant figure. It's closer to 20 than it is to 10. And finally, £50.99, if we round that to one significant figure, that'll be £50. So we've rounded all those figures to one significant figure. Now let's work out the calculation. So if we were to work it out exactly, we would do 31 times £196.50, but we're going to do 30, so it's approximately equal to 30 multiplied by 200. So we'll do that bit first of all, and then we'll get that answer, and we'll add together what we get whenever we do 20 multiplied by 50. Whenever we round these to one significant figure, instead of doing 19 times £50.99, we're going to do 20 times £50. So let's see what we get. So 3 times 2 is equal to 6, and add on 1, 2, 3 zeros, so that's going to be £6,000 plus 2 times 5 is 10, and then add on our 2 zeros, 0, 0. So we've got 6,000 plus 1,000, and that's equal to £7,000. So our estimate for the total cost would be £7,000. And let's just check it and see what it would be exactly. So 31 TVs at £196.50 plus 19 multiplied by £50.99 is equal to £7,060.31. So we're only just over £60 out. So it's a pretty good estimate. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So in question number 10, we're told that Jack was asked to work out 88.78, subtract 19.44, divided by 9.84. And his answer is 10.99. And by rounding each number to the nearest 10, show that his answer is incorrect. Okay, so let's round each of these numbers to the nearest 10. So that's approximately equal to, if we round them all to the nearest 10, 88.78 to the nearest 10 would be 90. Subtract 19.44 to the nearest 10 would be 20. 0.84 to the nearest 10 would be 10. So we've got 90 subtract 20 divided by 10. That's our estimate. So 90 subtract 20 divided by 10. 90 subtract 20 is equal to 70, and then divided by 10. And 70 divided by 10 is equal to 7. So our estimate is 7. But Jack's answer is 10.99, and that's pretty far out. So I think that shows that Jack is incorrect. And I've just written down his answer should be approximately 7. And actually, if we go back up, if we do that, so let's just work it out. 88.78 subtract 19.44 over 9.84, that's equal to 7.04 and so on. So his answer of 10.99 is pretty far out. Okay, let's look at our next question, question number 11. So question number 11, we've been asked to estimate 31 multiplied by 398 over 61. So let's round these numbers to one significant figure. So this would be approximately equal to 31. Well, if we round that to one significant figure, we would choose 30. 398, if we round that, that'll be 400 to one significant figure, over, and 61 to one significant figure will be 60. So then if we work this out, we've got 3 times 4 is equal to 12, and then we've got 1, 2, 3 zeros, 1, 2, 3, and then that's divided by 60. So we're going to do 12,000 divided by 60. There's a few different ways you could approach this. You could cancel it down and then write 1,200 divided by 6, just dividing both the numerator and denominator by 10, and then 1,200 divided by 6 would be equal to 200. So that's one approach. Or you could use the bus shelter method here, and that's what I'm going to do. So 12,000 divided by 60. How many 60s go into 1? 0, remainder 1. How many 60s go into 12? 0, remainder 12. How many 60s go into 120? That's 2. And then how many 60s go into 0? That's 0 and 0. So that's equal to 200. So our estimate is 200. And again, let's work this out and see what it is. 31 multiplied by 398 and then divided by 61 is 202.26 and so on. So that's pretty close. Okay, let's look at our next question, question number 12. So question number 12, we've been asked to estimate the value of 9.03 plus 19.87 times 3.11 subtract 4.97. So what we're going to do in this question is we've been asked to estimate it, so we're going to round these numbers, but also in this one you need to be careful. Remember your order of operations. So does it have any brackets? No. Now here some people use O for order. I use O for order. Some people use I for indice or index, so on. So there's some people use different letters here for this next one, but I use O for order. That means any squaring or cubing or cube rooting. Some people use I and so on, but it just means are there any squareds or cubes or square roots and so on? No. Any divisions or multiplications? Yes. So we're going to have to do this multiplication first, and then finally additions and subtractions will work from left to right. But the first thing we need to do in this calculation is when we round these, we're going to do the multiplication first. So let's round them all to one significant figure. So it'll be approximately equal to, well, that's going to be 9. 9.03 is approximately 9 plus 19.87. So rounding that to one significant figure would be 20. Multiply by 3.11 to one significant figure would be 3. And subtract 4.97, well, to one significant figure, that would be 5. So we've rounded those to one significant figure, and we've now got 9 plus 20 times 3, subtract 5. Now we have to do the multiplication first here. So you're going to do 20 times 3, and 20 times 3 is equal to 60. So what I'm going to do is I'm going to now write down, I'm going to keep the 9 there, keep the plus sign there, and 20 times 3 is equal to 60. So I'm then going to write 60, and then we've still got the subtract 5. So we've just worked out this part and put it in the middle. So we've got that 60 there. Now we've just got additions and subtractions, and when you just have additions and subtractions, you just work from left to right. So let's work this out. 9 plus 60 is equal to 69. Take away 5 would be 64. So our estimate is 64. And let's just work this out and see how close we are. So 9.03 plus 19.87 multiplied by 3.11 subtract 4.97 is equal to 65.8557. So that's pretty close. And that's it. So let's look at our next question, question number 13. Okay, let's have a look at our next question, question number 13. So question number 13, we've been asked to work out an estimate for 31.1 multiplied by 19.4 all over 3.98 multiplied by 5.04. Okay, so let's round these numbers to one significant figure. So that'll be approximately equal to 31.1. Well, it's closer to 30 than it is to 40, so we're going to go for 30. Multiplied by 19.4. Well, so it's in between 10 and 20, so it's closer to 20 than it is to 10. So multiply by 20. All over 3.98. Well, that's closer to 4 than it is to 3, so that's 4. Multiplied by 5.04, it's closer to 5 than it is to 6, so 5. So we've got 30 times 20 all over 4 times 5. That's our so we're going to use those figures for our estimate. Okay, so let's work out the numerator. 30 times 20, well, 3 times 2 is equal to 6, and then we've got 2 zeros, that's 600, over 4 times 5 is equal to 20. So that's equal to 600 divided by 20. Now we just need to work out what 600 divided by 20 is. So 600 divided by 20, again, there's a few different approaches. We could cancel down the fraction, 600 over 20. We could divide both of them by 10. So excuse my line there. Divide both of them by 10. That's equal to 60 over 2. And then 60 divided by 2 is equal to 30. That's one approach. Or you could use the bus shelter method. 600 divided by 20. How many 20s go into 6? 0 remainder 6. How many 20s go into 60? That's 3. And how many 20s go into 0? That's 0. So that's equal to 30. So our estimate for 31.1 multiplied by 19.4 over 3.98 times 5.04 is equal to 30. So that's our estimate. And let's just check and see how close we were. 31.1 multiplied by 19.4 divided by 3.98 multiplied by 5.04, close brackets. And I get that's equal to 30.0779. So that's pretty close. Okay, let's have a look at the next question, question number 14. So question number 14, we've been asked to estimate the value of 702.1 plus 299.3 all over 1.9 multiplied by 5.1. Okay, so let's round these to one significant figure. 702.1, well, that's our 700, that's to one significant figure, plus 299.3, well, we're going to choose 300 there, all over 1.9, well, I'm going to choose 2, and multiply by 5.1, we're going to choose 5, just rounding all those numbers to one significant figure. Okay, so now let's work this out. 700 plus 300, that's equal to 1,000, divided by 2 times 5 is equal to 10. So we've got 1,000 divided by 10. And 1,000 divided by 10 is equal to 100. So that's our estimate, 100. And let's just check our answer and see how close we were. On the numerator, 702.1 plus 299.3 all over 1.9 multiplied by 5.1. And that's equal to 103.34 and so on. So that's pretty close. Okay, let's look at our next question, question number 15. So question number 15 says, a merchandise stall sells 49 bubble wands for $29.75 each and 196 pins at $9.95 each. And we've been asked to work out an estimate for the total money paid for these items. Okay, so here, because it's an estimate, I'm going to round these numbers to one significant figure. So instead of 49 bubble wands, I'm going to choose 50. Instead of $29.75, I'm going to choose $30. Instead of 196 pins, I'm going to choose 200 pins. And instead of $9.95, I'm going to choose $10. So I've just rounded all those figures to one significant figure. So now what I'm going to do is I'm going to work out how much was paid for the bubble ones, or an estimate for how much was paid for the bubble ones. So we're going to use these numbers. So we're going to do 50 multiplied by 30. So that's our estimate. And 5 times 3 is equal to 15. And then we've got 2 zeros. So our estimate for the money that was received for the bubble ones is $1,500. Okay, now let's look at the pins. Our estimate, we're estimating that 200 of those were sold at $10 each. So if we round those, 200 times 10 is equal to 2,000. So our estimate for the amount of money that was received for the pins is $2,000. And then if we add the two totals together, that's equal to $3,500. So that's our estimate, $3,500. And let's just check and see if we were to do 49 multiplied by 29.75 and add 196 times 9.95, that's equal to $347.95. Okay, and let's look at our next part, part B. Part B says, is our answer to A an underestimate or an overestimate? So let's have a look at the actual figures. So there's 49 bubble ones, but we've rounded that up to be 50. And the price was $29.75, we rounded that up to be 30. And 196 pins were sold, but we rounded that up to be 200. There's a common trend here, we're rounding everything up. And $9.95, we've rounded that up to be $10. So we've rounded up not only the number of items sold, but also the prices. So when we work out that calculation, it's going to be bigger than the actual amount made by selling those items. And we've actually looked and seen on our calculator that's the case. Obviously it's a non-calculator question, so you wouldn't be able to check, but we've already found that it's bigger. And the reason is we've rounded up the quantity of items sold and also the prices. And if you're rounding everything up, well, if you're going to add them up, it's going to be bigger than the actual amount. So it's an overestimate. So let's explain that. And that's it. I've just explained that it's an overestimate as we rounded up the quantities and the prices. Okay, let's look at our next question, question number 16. So question number 16 says 1.97 litres of water flows from a tap every 15 seconds. And we've been asked to estimate how many litres will flow from the tap in 1 hour. Okay, so we want to estimate how many litres will flow from the tap in 1 hour. So let's first of all look at these quantities. So it's 1.97 litres of water flows from the tap every 15 seconds. So because it's an estimate, I'm going to round this and I'm going to say it's 2 litres. So I'm going to say that 2 litres of water flows from the tap every 15 seconds. And I'm going to actually use that to work it out. So 2 litres of water flows every 15 seconds. Now if we think about a minute there's going to be 15, 30, 45, 60 seconds. So if we take our 2 litres, and we know that there's 2 litres every 15 seconds, if we do 2 multiplied by 4, because there's 4 lots of 15 seconds in a minute, that tells us how many litres, or our estimate for how many litres of water will flow from the tap in 1 minute. So let's do that. So let's take the 2 litres and multiply by 4, because there's 4 lots of 15 seconds in a minute. And that's equal to 8. So our estimate is that there's 8 litres in 1 minute. Now we want to estimate how much water flows from the tap in 1 hour, so that's 60 minutes. So we're going to multiply this by 60. So 8 litres multiplied by 60, and let's see what we get. So 8 times 6 is equal to 48, and then we've got our 0. So my estimate for the amount of water that will flow from the tap in 1 hour is 480 litres, and that's it. Okay, so let's have a look at our next question, question number 17. So question number 17 says, circle the number that is closest in value to 20.2 cubed. Okay, so 20.2 cubed. Well, I'm going to do an estimate. I'm going to work out 20 cubed and see what that is. So 20 cubed would be, because it's cubed, we're going to multiply by itself and by itself again. So we're going to take 3 20s and multiply them together. Well, if we work this out, so 20 times 20 is equal to 400, and times another 20 would be equal to 8,000. Or another way to do it is 2 times 2 times 2 is equal to 8, and then add on the 3 zeros, so 8,000. So my estimate to this calculation is 8,000. And actually, if we consider it, it was 20.2 and we rounded it down. So that means that 8,000 will be an underestimate. So that means that in terms of our options, 8,000 will definitely be the closest one. If that's an underestimate, then actually 20.2 will be bigger than 8,000. So it's definitely the closest one out of all those options. Okay, so let's have a look at our next question, question number 18. So question number 18 says, work out an estimate for 20.2 multiplied by 698.1 over 19.8 multiplied by 5.3. Okay, so I'm going to round these figures to one significant figure. So 20.2, I'm going to use 20, multiplied by 700, over 19.8, well, if I round that to one significant figure, that'll be 20 as well, multiplied by, and then 5.3, I'm going to round that to be 5. Okay, so now let's work these out. The numerator, 2 times 7 is 14, and then 1, 2, 3 zeros. And the denominator, 2 times 5 is equal to 10, and put on the 0. So now if we do 14,000 divided by 100, we're going to take off 2 zeros, so that'll leave us with 140, and that's it. So my estimate for this calculation would be 140. And just out of interest, I'm going to get my calculator and work it out and see what the answer would actually be. 20.2 multiplied by 698.1 over 19.8 times 5.3 is equal to 134.3779 and so on. So that's pretty close. Okay, let's look at our next question, question number 19. So question number 19, we've been asked to work out an estimate to 8.7 multiplied by 20.3 over 8.898 subtract 6.01. So here I'm going to round the numbers to one significant figure, 8.7, so that's closer to 9 than it is to 8. 20.3, well, that's closer to 20 than it is to 30. 8.898, that's closer to 9 than it is to 8, so that's 9. Subtract 6.01, that's closer to 6 than it is to 7. So now if we work out the numerator, 9 times 2 is equal to 18, and put on a 0. And the denominator, 9 subtract 6 is equal to 3. So we've got 180 divided by 3, and that would be, well, 18 divided by 3 is 6, so that'll be 60. So our estimate is 60. So let's just check this and see how close it was on my calculator. And obviously it's a non-calculator question, so I'm just checking this out of interest. So 8.7 multiplied by 20.3 over 8.898 subtract 6.01 is equal to 61.15 and so on. So 60 is pretty close. It's a good estimate. Okay, let's look at our next question, question number 20. Okay, so let's have a look at our next question, question number 20. So question number 20 says, in a theatre there's 29 rows and in each row there's 32 seats and each ticket costs £19.75p. And we've been asked to work out an estimate for the total income from ticket sales. Okay, so it's an estimate, so let's round these figures. So instead of 29 times 32 to work out the number of seats, we're going to do 30, just rounding it, times 30, and that'll be a good estimate. And instead of using £19.75, we'll use £20. So that's going to be the figures that we'll use for our estimate. So 30 times 30, that gives us an estimate of how many seats there are. 3 times 3 is equal to 9, and then add on 2 zeros. And then that means there's 900 seats. If we do 900 multiplied by 20, that'll tell us our estimate for the total income from ticket sales. 9 times 2 is equal to 18, and then 1, 2, 3 zeros. 1, 2, 3. That's £18,000. That's our estimate, £18,000. And let's just check that. 29 multiplied by 32 is equal to 928. So actually our estimate's a little bit under in terms of the number of seats. But then whenever we multiply by the price, we get an estimate of the actual value would be, if it was a calculator question, would be 18,328. So it's pretty close. It's a good estimate. Okay, let's look at the next question, question number 21. So question number 21 says, estimate how many books costing $7.05 can be bought for $424. So imagine you went into the shop and you had $424, so maybe you're in America or Canada or somewhere like that where they use dollars, Australia perhaps, and you've got $424 and you want to buy as many books as possible, and each one of those books costs $7.05, and you want to estimate roughly how many you're going to get. Now in terms of this question, I had considered rounding them to one significant figure, but actually with these figures, with it being 424, and if I round that to one significant figure I get 400, and with $7.05 we get $7, and if we do 400 divided by 7, it's not actually that nice in terms of a division. So what I've decided to do here is I have rounded the cost to be $7, and I'm going to use $7, but instead of rounding this $424 all the way down to 400, in this case I'm going to round this to $420. Now the reason that I'm doing that is I know that 42 is in the 7 times tables. I know that if we count up in sevens, 42 is going to be in the 7 times tables. So I know that I can do 420 divided by 7 a lot more easily than I can do 400 divided by 7. And remember, these are estimations. So a lot of questions you will typically round to one significant figure, but sometimes, perhaps in real life situations, it might actually make sense to round to a nearby number that you know will be a good number that will work for you for the purposes of your estimation. So if I went into the shop with $420 and each of the books cost $7, we would do 420 divided by 7. And how many 7's going to 4? 0 remainder 4. How many 7's going to 42? Well, 7 times 5 is 35, so that'll be 6. And how many 7's going to 0? That's 0. So that's 60. So my estimate for the number of books that can be bought would be 60. So 60 books. And let's just check and see how many can actually be bought. If we have $424 and we divide it by 7.05, that's equal to 60.141 and so on. You don't actually have enough money for the 61st book, so the answer actually would be 60 books. That's quite a good estimate there. Okay, let's look at our next question, question number 22. So question number 22 says, by writing each number correct to one significant figure, use estimations to show that 60.4 multiplied by 19.7 over the cube root of 7.96 is approximately equal to 600. So let's start off with the numerator. 60.4 to one significant figure is closer to 60 than it is to 70. Multiplied by 19.7, well, it's closer to 20 than it is to 10. And then over the cube root of 7.98, well, that's closer to 8 than it is to 7, so the cube root of 8. And then if we work this out, well, in terms of the numerator, 6 times 2 is equal to 12, and then we've got 2 zeros. And then in terms of the denominator, we've got the cube root of 8. Well, the cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. So that means the cube root of 8 would be 2. And then finally, we've got 1,200 divided by 2. Well, that's equal to 600. And that's it. We've shown what we needed to show. So yes, so if we round these numbers to one significant figure and work it out, we do get that's approximately equal to 600. And that's it. Okay, let's look at our next question, question number 23. So question number 23, we've been asked to work out an estimate for 203 multiplied by 9.93 all over 0.511. So I'm going to round these figures to one significant figure. So if we round them to one significant figure, we would have on the numerator 200 multiplied by 10. And then on the numerator, we've got 0.511. Well, to one significant figure, that'll be 0.5. We'd round that to 0.5 because it's closer to 0.5 than it is to 0.6. So now if we do 200 times 10, that's 2,000 divided by 0.5. Now, in terms of doing 2,000 divided by 0.5, there's a few different ways you could approach this. One approach is, well, you're saying how many halves go into 2,000? Well, in one whole, there's 2 halves. In 2 wholes, there's 4 halves. In 3 wholes, there's 6 halves. In 4 wholes, there's 8 halves. In 2,000 wholes, there's 4,000 halves. So the answer would be 4,000. So just knowing that whenever you divide by 0.5, you're seeing how many halves go into something, that actually be twice as many. Now, another way we could approach this is if we were doing 2,000 divided by 0.5, 2,000 divided by 0.5. When we're doing division, we can multiply both what we're dividing and what we're dividing by the same number, perhaps 10 or 2 or 100 and so on, and it'll still give you the same answer. For instance, if we had 8 divided by 2, that's equal to 4. If we have 80 divided by 20, that's also equal to 4, and so on. So if we have both these numbers and we multiply them both by 10, we would get 20,000 divided by 5, just multiply both of those numbers by 5, and then we could use the bus shelter method. We could do 20,000 divided by 5, just multiplying both of these numbers by 10 and doing 20,000 divided by 5. How many 5s go into 2? 0 remainder 2. How many 5s go into 20? That's 4. How many 5s go into 0? That's 0. How many 5s go into 0? That's 0. And how many 5s go into 0? That's 0. So that's 4,000. So again, we've got the answer 4,000. So if you're dividing by a 0 point number, rather than dividing by the 0 point number, you could multiply them both by, perhaps in this case, 10 works out quite nicely. If it was 0.05, you could times them both by 100 and so on. And that's it. So our estimate for this calculation would be 4,000. And let's just check it. Again, it's a non-calculator question, but we're just checking it out of interest. If we have 203 multiplied by 9.93 and we divide that by 0.511, the answer is equal to 3,944.79. So it's pretty close to 4,000. So it's a good estimate. Okay, let's look at our next question, question number 24. So question number 24 says Alistair is estimating the value of 60.4 multiplied by 91.18, and he rounds each number to one significant figure. So instead of 60.4, he would use 60. Instead of 91.18, he would use 90. And then we're going to multiply them together. So we've been asked to work out his estimate. So we've rounded the numbers to one significant figure. 6 times 9 is equal to 54. And then we've got 2 zeros. So his estimate would be 5,400. Okay, and then if we carry on, Alistair says his estimate is an overestimate. Is Alistair correct? Explain your answer. So he's saying that his answer is an overestimate. So he's saying that his answer is actually bigger than the real thing. So let's go back up. So he rounded 60.4 down and he rounded 91.18 down. So his estimate will actually be lower than the real thing. If we actually worked out this, it'll be bigger than this. 60.4 times 91.18 will definitely be bigger than 60 times 90. So that means that he's actually rounded down. So his is an underestimate. So let's explain that. And I've just explained that no, he's rounded both values down, so he is underestimated. Okay, let's look at our next question, question number 25. So question number 25 says, use approximations to estimate the value of 4.02 squared plus the square root of 102 all over 0.51. Okay, so let's choose some sensible numbers here. So what I'm going to do is, instead of 4.02 squared, I'm going to choose 4 squared, and then plus. And instead of the square root of 102, I think if we do the square root of 100, that's pretty close, and we can square root 100 quite nicely. And then divided by, and instead of dividing by 0.51, I'm going to round that to be 0.5. So we're going to work out 4 squared plus the square root of 100 divided by 0.5. So let's do that. 4 squared, well, 4 times 4 is 16. The square root of 100 is 10, because 10 times 10 is 100. And then we're going to divide that by 0.5. Okay, 16 plus 10 is equal to 26, divided by 0.5. And now we just need to divide by 0.5. Now, dividing by 0.5 is quite nice. You can just double it. So if we double 26, the answer will be 52. So that's quite nice. Whenever we divide by 0.5, you just double what you're dividing, because you know that twice as many halves will go into it. Or alternatively, if we had 26 and we're dividing it by 0.5, we could times both of them by 10 to get 260 divided by 5. And then we could do 260 divided by 5. How many 5s go into 2? 0, remainder 2. How many 5s go into 26? Well, 5 5s are 25, so that'll be 5, remainder 1. And how many 5s go into 10? That's 2. So again, 52. So our estimate is 52. And that's it. Okay, let's look at our next question, question number 26. So question number 26 says, we've been asked to use approximations to estimate the value of 4.12 multiplied by 1.89 divided by 0.21. So let's round these. So 4.12, well, that'll be 4, and then times by 1.89, I'm going to choose 2, and then divided by 0.21, well, it's closer to 0.2 than 0.3, so let's choose 0.2. Okay, so that's what it's approximately equal to. And then 4 times 2 is equal to 8 divided by 0.2. So we now just need to do 8 divided by 0.2. So if we're working out 8 divided by 0.2, well, it's not as easy as dividing by 0.5, because 0.5 we just know to double is twice as many halves in something. 0.2 is a fifth, so we're saying how many fifths are in 8. And how many fifths would be in 8? Well, there's 5 fifths in 1 whole. There's 10 fifths in 2 wholes. In 8 wholes, it would be 40 fifths. So the answer would be 40. Or actually, the way I would do a question like this is, I would say 8 divided by 0.2. I'm going to times both of these numbers by 10 to get a nice number to divide by. So that'll be 80 divided by 2. And 80 divided by 2 is equal to 40. Just multiply both of those numbers by 10. And because remember that whenever we multiply both the number you're dividing and the number you're dividing by a number such as 10, it's going to give you the same answer. So if 80 divided by 2 is equal to 40, the 8 divided by 0.2 is equal to 40 as well. So that means that the answer will be 40. That's our estimate. And that's it. So our estimate is 40. Okay, so let's have a look at our next question, question number 27. So we've been asked to work out an estimate for 5.14 squared over 0.398. Okay, so let's round these numbers. So instead of using 5.14 squared, I'm going to write 5 squared divided by, and instead of 0.398, I'm going to write 0.4, just rounding those to one significant figure. 5 squared is equal to 25, because 5 times 5 is equal to 25, and we're going to divide that by 0.4. Now, in terms of dividing by 0.4, I'm going to take both the numbers, the 25 and our 0.4, because we're doing 25 divided by 0.4. I'm going to multiply both of those numbers by 10. So that would give us 250 divided by 4. Just multiplying both of those numbers by 10, because remember, if we multiply both the number we're dividing and the number we're dividing by both the same number, we'll get the same answer. Okay, I suppose except for 0. Okay, so 250 divided by 4, I'm going to half it and half it again. So half of 250 would be 125, and half of 125 would be 62.5. So the answer would be 62.5, so 62.5. And that's it. Or you could do the Bush-Shelton method there, 250 divided by 4. How many 4s go into 2? 0, remainder 2. How many 4s go into 25? That'll be 6, which is 24, remainder 1. Now we know this is going to be a decimal number, so I'm going to put decimal point at 0. How many 4s go into 10? 2, remainder 2. And how many 4s go into 20? That's 5. So the answer is 62.5. That's our estimate for this calculation. And actually, just out of interest, if we work out 5.14 squared and divided by 0.398, we get an answer of 66.38. So that's pretty close. Okay, let's look at our next question, question number 28. So question number 28, we've been asked to work out an estimate for 4.086 multiplied by 2.992 all over 0.192. So let's round these numbers to one significant figure. So that would be approximately equal to 4 multiplied by 3 divided by 0.2. Just rounding those numbers to one significant figure. 4 times 3 is equal to 12, and we're going to divide it by 0.2. So again, dividing by 0.2, I'm going to write down 12 divided by 0.2. Now I don't like dividing by 0.2, so I'm going to multiply both of these numbers by 10. So that would give us 120 divided by 2. And 120 divided by 2 is equal to 60. So that means that 12 divided by 0.2 would also be equal to 60, because remember, when we multiply both the number we're dividing and the number we're dividing by numbers such as 10 or 100 and so on, we get the same answer. So that means our estimate is 60. And that's it. Okay, let's have a look at our next question, question number 29. So question number 29 says, use approximations to estimate the value of 596.4 multiplied by 2.06 all over 0.521. So what we're going to do here is we're going to round each of these numbers to one significant figure. So instead of 596.4, I'm going to use 600 multiplied by 2. And instead of 0.521, I'm going to use 0.5. So I've rounded each of those numbers to one significant figure. Now let's work this out. So 6 times 2 is equal to 12, and then we'll add on our 2 zeros, that's 1,200 divided by 0.5. Now we talked about dividing by 0.5 earlier, where if we divide by 0.5 we can double. So if we have 1,200 divided by 0.5, that'll be equal to 2,400. So the answer would be 2,400, because remember, in one whole there's 2 halves, in 5 wholes there's 10 halves, in 1,200 wholes there's 2,400 halves, and so on. So the answer would be 2,400. Now you could, if you wanted to, multiply both of these numbers by 10 to get 12,000 divided by 5, and then do the Bus-Shelter method, and again you would get 2,400. And that's it. Let's have a look at our next question, question number 30. Okay, so question number 30, we've been asked to write down an estimate for the square root of 20. Now, whenever we're dealing with questions like this, where we're having to estimate the square root of something, I like to think of the square numbers. So let's work out the square root of 16, because that's the square number below 20. That's equal to 4. And then the square number above 20 would be 25. So the square root of 25 is equal to 5. So the square root of 16 is 4, and the square root of 25 is 5. So the square root of 20 is going to be in between 4 and 5. Now, if it was the square root of 24, it'd be much closer to 5. If it was the square root of 17, it'd be much closer to 4. With it being the square root of 20, I think they'd be in the middle somewhere, so maybe a 4.4, 4.5, 4.6, something like that. So I'm going to go for 4.5. That's my estimate for the square root of 20. And out of interest, let's just see what the square root of 20 is. The square root of 20 is equal to 4.47, which rounds to 4.5, to one decimal place. So that's a good estimate. Okay, our next one, we've been asked to work out an estimate for the square root of 51. So the square root of 51, well, it's 49. That's just below 51. That's equal to 7. And the square root of 64, which is above 51, is equal to 8. Now, 51 is much closer to 49 than it is to 64. So I'm going to go for a number that's close to 7. So perhaps 7.1. So that's my estimate, 7.1. And let's just see what the square root of 51 is. The square root of 51 is equal to 7.14, which to one decimal place would be 7.1. So that's good. Okay, question number 32. Question number 32, we've been asked to work out an estimate for the square root of 78. So 78, well, the square number below 78 would be 64. The square root of 64 is equal to 8. And then in terms of the square number above 78, that'll be 81. So the square root of 81 is equal to 9. So 78, well, that's closer to 81 than it is to 74. So I'm thinking numbers such as 8.8 or 8.9. I'm going to choose 8.9. So my estimate is 8.9. And let's just work out and see what it is. The square root of 78 is equal to 8.83. So 8.8 was a little bit closer, but 8.9, that's my estimate. So around about that region. Okay, so if you wrote 8.8, because it's maybe a little bit lower down than maybe the square root of 80 or the square root of 81, 8.8 would be a good estimate. But you choose a number that's pretty close to 9, but obviously not close to 8. So 8.8 or 8.9 would be good estimates. Okay, let's look at our next question, question number 33. So question number 33, we've been asked to work out the cube root, or estimate the cube root of 30. So let's consider our cube numbers. Our cube numbers are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. So the cube root of 30, it's going to be, well, if we consider the cube root of 27, that's equal to 3. And the cube root of 64 is equal to 4. So the cube root of 30 is much closer to the cube root of 27 than it is to the cube root of 64. So I think perhaps 3.1 would be a good estimate. So my estimate would be 3.1. Okay, let's look at our next question, question number 34. So question number 34, we've been asked to circle the number that's closest in value to 79.7 divided by 0.0206. So let's round our numbers to one significant figure. So 80 on the numerator, so pretty approximately equal to 80 over, and then the denominator will be 0.02. So just rounding those numbers to one significant figure. So let's work out what 80 divided by 0.02 is. Now here I'm going to multiply both the numerator and denominator by 100. Rather than multiply by 10 in this case, I'm going to multiply both of them by 100. Remember, it'll still give us the same answer. So we multiply both the numerator and denominator by 100. We would have 8,000 multiplying 80 by 100 is 8,000, divided by, multiplying this number by 100, 0.02 by 100, we would move the two columns to the left, so that'll be 2. And 8,000 divided by 2 is equal to 4,000. So that means that 79.7 divided by 0.0206 will be approximately 4,000. So there it is. So that's the number that's the closest in value in terms of that list to the answer to that question. And that's it. Okay, let's look at our next question, question number 35. So question number 35, we've been asked to estimate 594 multiplied by 4.03 over 0.396. So let's round these numbers to one significant figure. So 594 is closer to 600 than it is to 500. Multiplied by, well, 4.03 is closer to 4 than it is to 5. And 0.396 is closer to 0.4 than it is to 0.3. So we've got 600 times 4 divided by 0.4. So let's work out the numerator. 600 times 4. 6 times 4 is equal to 24, and then add on the 2 zeros, and then over 0.4. So we just need to work out what 2,400 divided by 0.4 is, and then that will be our estimate. So here I'm going to multiply. We've got 2,400 divided by 0.4. Let's multiply both of those numbers by 10, so we've got 24,000 divided by 4. And to work out 24,000 divided by 4, we'll half it and half it again. And half of it is 12,000, and half again is 6,000. So the answer will be 6,000. So that's our estimate, 6,000. And that's it. Okay, so that's question number 35. Let's have a look at question number 36. Okay, let's have a look at our next question, question number 36. So question number 36, we've been asked to use approximations to estimate the value of the square root of 50.77 divided by 0.513. So let's round these numbers to one significant figure. So that'll be approximately equal to the square root of 50 divided by 0.5. Now 50 divided by 0.5, well, how many halves go into 50? That's 100. So that would be the square root of 100. And the square root of 100 is 10. So that means that the square root of 50.77 over 0.513 would be approximately equal to 10. And out of interest, let's just see what it is. So the square root of 50.77 over 0.513 is equal to 9.948. So that's pretty close. So that's it. Our answer is 10. Okay, and let's look at our last question, question number 37. So question number 37, we've been asked to estimate the value of 803 multiplied by 2.97 over 0.613. So let's round these numbers to one significant figure. So that's approximately equal to 800 multiplied by 3 over 0.6. So I've just rounded each of those numbers to one significant figure. 803, 800, 2.97, 3, and 0.613, 0.6. Now let's work this out. So the numerator, 8 times 3 is 24, and put on the 2 zeros, over, and then we had 0.6 on the denominator. So we've got 2,400 divided by 0.6. I don't like dividing by 0.6 because it's a decimal number, so let's multiply. We've got 2,400 divided by 0.6. Let's multiply both these numbers by 10. So we get 24,000 divided by 6. And then if we do 24,000 divided by 6, well, 24 divided by 6 is 4, and then we've got our 3 zeros. So the answer would be 4,000, and that's it. So my estimate for this question is 4,000, and that's it. And that's it. So in this video, we've gone through the video solutions to the Corbettmaths Practice Questions on estimation. I really hope you found this video useful. If you need any extra help on estimation, if you go to Corbettmaths and go to the videos or worksheet section and scroll down to video number 215, there's a dedicated video tutorial there on estimation. Alternatively, scan the QR code. But again, I really hope you found this video useful. If you have found it useful, please like and please subscribe to the YouTube channel. Thank you. Cheers. Bye.